So, what if the smartest part of a smart device wasn't its brain, but its heart? Today, we're going to dive into AI Chip, a company that's completely flipping the script on AI by putting it in the one place we'd never think to look, the power controller.
Okay, so from factory robots to smart cash registers, everybody's trying to get AI running on their local devices. You know, edge AI. They absolutely need it for things like safety, for efficiency. But here's the problem. The whole thing is kind of broken. The economics just don't add up, and it's created this massive logjam for innovation. And this really is the core question, isn't it? On the one hand, everyone wants and needs intelligent devices everywhere. But on the other, they're just too expensive and, frankly, not reliable enough for mission-critical jobs. This gap is what's holding back a true revolution in the Internet of Things.
Right now, you're basically stuck between a rock and a hard place. You could try to use the cloud for your AI, but for critical stuff, the network lag, the privacy issues, it's a non-starter. So the other option is to stick a general-purpose AI chip on the device itself. But these things are basically tiny, power-guzzling supercomputers. Way too expensive and way too inefficient for most applications.
So if both of those paths are basically dead ends, what's left? Well, this is where AI Chip comes in with a totally radical shift in thinking. They say, forget the brain. The real revolution starts in the power system itself. You see, the conventional wisdom has always been to just build a bigger, faster brain. Just throw more processing power at the problem. But that's exactly what got us into this mess of high costs and insane power consumption in the first place. The real breakthrough, according to AI Chip, comes from putting that intelligence at the most fundamental layer of any device, its heart, the system that actually manages its lifeblood, its power.
And the logic here is it's brilliant. AI Chip builds intelligence directly into the power management controller, or the PMC. This is the perfect spot for it. Why? Because it's always on, it's the very first thing to see an electrical problem, and it already controls the device's most basic functions. It is the ultimate leverage point for making a device truly reliable.
Okay, a smarter heart sounds great, but what does that actually mean? How does it really work? Let's get into the mechanics of what AI Chip calls governed power.
So at the core of all this is something called XR governance. The easiest way to think about it is like a dedicated operating system, but just for the power. It's this foundational rulebook that says exactly how the device has to behave, it logs everything for later, and it plans out safe escape routes from any possible fault. And this isn't just a single AI. It's this really clever dual brain model. The first brain is the algorithm. Think of this as the super strict safety guardrails that can never ever be broken. The second brain is the machine learning part, and it has to operate inside those guardrails. Its job is to be the smart optimizer, making things more efficient and, critically, spotting the tiny electrical clues that signal a problem is coming long before it actually fails. So how does this actually save a device in the real world? Well, let's look at this ride-through feature. Imagine there's a sudden voltage drop, a little glitch that would normally crash your typical device. The AI sees it instantly and engages a capacitor bank. This thing acts like a tiny built-in power backup. It just seamlessly bridges that power gap, keeping the whole system running without a single hiccup. No crash, no downtime, nothing. Now, groundbreaking tech is one thing, but having a credible plan to actually get it to market is a whole other beast. And this is where AI Chip is really smart, building trust with a super pragmatic strategy.
See, instead of gambling millions on a custom chip right out of the gate, they have this clever three-stage approach. First, they use these flexible, reprogrammable chips called FPGAs to build and test prototypes quickly. Then, in stage 2, they prove the solution works with a couple of key customers and pilot programs. And only then, after it's been battle-tested in the real world, do they move to stage 3, making a custom chip designed for low-cost mass production. It's a strategy that just systematically removes risk every step of the way.
And this isn't just some plan on a whiteboard. They have the absolute perfect team to execute it. Their head of silicon, deep expertise in that exact FPGA to custom chip journey. Their co-founder has already scaled a company's revenue into the tens of millions. And the founder brings over 30 years of experience building this exact kind of hardware. I mean, every single stage of their roadmap is covered by someone who's been there and done that.
So we've got the tech, the mechanics, the plan, and the team. What does this all actually add up to? Let's bring it full circle and see what this really unlocks.
So what's the ultimate payoff here? Well, for any company that's managing a huge fleet of critical devices, this intelligent power controller means way less downtime, much lower service costs, and a massive boost in overall reliability. It's the thing that finally makes mission-critical AI affordable and practical enough to actually use at scale.
And to put a real number on this, check this out. Their ride-through module was tested on a system that normally sips just 71 watts. It got hit with a sudden massive power surge of nearly 280 watts, and it didn't crash. That's not just a spec on a datasheet. That's the real-world difference between a dead machine needing an expensive service call and one that just keeps on working.
And this all boils down to AI chip's central vision, that huge, nagging gap in IoT intelligence. It finally closes when you make the power and control system the very foundation, the substrate for your AI.
And that really brings us to a final powerful thought. For years, the entire industry has been obsessed with giving our devices bigger brains. AI chip is showing us how to give them smarter hearts. So the question now is, what becomes possible? What can we build when our most critical machines are not just intelligent, but fundamentally, provably reliable?